The first Snickers bar rolled off the production line in 1930, named after the Mars family's favorite horse. Over 90 years later, the recipe has barely changed, but the manufacturing process has evolved into an astonishing feat of engineering that most consumers never see. In this exclusive look inside Mars Inc.'s production facilities, we'll reveal exactly how raw peanuts transform into the world's best-selling candy bar through a precisely choreographed system of roasting, mixing, cooling, and enrobing. You're about to witness the hidden complexity behind a candy that sells billions of units annually across 6 continents. Did you know that every second more than 400 Snickers bars roll off production lines around the world? That's over 34 million bars each day. Yet few consumers understand the complex processes behind creating the foundational layers that give this iconic candy bar its distinctive texture and taste. The journey of a Snickers bar begins with its nougat base, a component far more sophisticated than most people realize. Inside Mars Wrigley's production facilities, the nougat creation starts with a precise mixture of corn syrup, sugar, salt, and water. This mixture isn't simply combined. It's heated to exactly 240 degrees Fahrenheit in large industrial kettles, equipped with temperature monitors that can detect fluctuations as small as half a degree. Even minor temperature variations at this stage would compromise the nougat's structural integrity in the finished product. Once the sugar solution reaches its target temperature, it moves to the next phase where it's carefully combined with fluffy beaten egg whites in massive industrial mixers. These aren't your standard kitchen appliances. Each mixer can process enough nougat for thousands of candy bars in a single batch. The integration of these ingredients follows a tightly controlled sequence, with egg whites being incorporated at specific intervals to achieve the perfect texture. In real time, you would see the nougat transform dramatically from a thin, translucent liquid into a thick, opaque substance with remarkable elasticity. This metamorphosis occurs as mechanical paddles continuously stir the mixture, introducing microscopic air bubbles that provide the nougat's characteristic lightness. Manufacturing engineers monitor this process constantly, checking both the viscosity and temperature to ensure each batch meets Mars Wrigley's exacting standards. After the nougat achieves optimal fluffiness, a state determined through both visual assessment and computerized testing, it travels through stainless steel pipes to a specialized screw mixer. Here, freshly ground peanut butter is introduced to the nougat mixture. This addition isn't just for flavor. The natural oils and proteins in the peanut butter integrate with the nougat matrix, enhancing structural stability while adding depth to the flavor profile. The screw mixer's rotating blades ensure uniform distribution of the peanut butter throughout the nougat. While the nougat preparation continues, a parallel process unfolds in separate stainless steel vats where the caramel layer takes form. The caramel formula combines corn syrup, carefully selected butter, condensed milk, granulated sugar, and a precise measure of salt. Unlike home caramel, which risks burning in open pans, the factory uses vacuum kettles that allow caramelization at lower temperatures, producing a more consistent result while minimizing the risk of scorching. The science behind caramel production requires rigorous oversight, with technicians monitoring not just temperature but also pressure, moisture content, and cooking time. The objective is to achieve a specific viscosity. Too thin, and the caramel would soak into the nougat layer below, creating a soggy, undifferentiated mass. Too thick, and it wouldn't properly bond with the peanuts that will be introduced later in the process. Each batch undergoes real-time testing using specialized rheometers that measure flow characteristics under different conditions. One might wonder how these distinct layers maintain their separation during assembly, rather than merging into an indistinguishable blend. The answer lies in strategic temperature management. Before the caramel application, the nougat sheet passes through a cooling tunnel that brings its temperature down to precisely 65 degrees Fahrenheit. When the 120 degrees Fahrenheit caramel is then applied, this temperature differential creates what engineers call a thermal boundary layer, a phenomenon that prevents molecular integration between the two substances while still allowing them to adhere firmly to each other. The temperature control systems throughout the facility represent some of the most advanced applications of thermodynamics in food production. Infrared sensors continuously scan the surface temperature of both components, and any deviation triggers immediate adjustments to ensure consistent quality. This precision allows Mars to achieve remarkable consistency. A Snickers bar produced in Waco, Texas will have virtually identical layer structure to one made in their Veghel facility in the Netherlands. As both the nougat and caramel preparations reach completion, these components advance toward the assembly area on separate conveyor systems that converge at precisely timed intervals. Here, they'll encounter the third critical ingredient that gives Snickers its distinctive texture: roasted peanuts. These aren't just any peanuts, but ones selected for specific size, oil content, and flavor profile, ensuring they'll integrate perfectly with the prepared foundation layers. As those perfectly selected peanuts converge with the nougat and caramel base, they begin an extraordinary journey through one of the most precisely engineered manufacturing systems in the food industry. The assembly line at the Master Foods facility in Waco, Texas, stretches nearly half a mile in length, with each Snickers bar traveling through a remarkable 28 distinct processing stations before it's ready for packaging. This extensive configuration isn't merely impressive. It's essential for meeting the staggering global demand for one of the world's most popular candy bars. The Nougat Foundation continues its journey along specialized conveyor systems where it meets the caramel peanut mixture. This convergence isn't random, but occurs through a meticulously timed and measured application process. Timing here is measured in milliseconds and distances in millimeters, all orchestrated to ensure a Snickers bar made in Texas is identical to one produced anywhere else in the world. What many consumers don't realize is that temperature control represents the most critical engineering challenge throughout this process. While most people focus on taste, Mars engineers are obsessed with maintaining precise thermal conditions. A variance of just 3 degrees Fahrenheit at critical stages can compromise texture, taste, and structural integrity. This narrow margin of error explains the extensive temperature monitoring systems installed at every stage of production. The caramel peanut mixture is deposited onto the nougat layer in precisely measured amounts to ensure consistent weight and flavor profile in every bar. These peanuts, now perfectly integrated with the caramel, create the distinctive middle layer that gives Snickers its characteristic crunch. The combined layers then enter a refrigerated tunnel that brings the temperature down to a stable 65 degrees Fahrenheit, creating the ideal consistency for the next critical operation. Cutting this continuous sheet into individual bars requires remarkable precision. The slitter machine is calibrated to the millimeter, transforming the endless ribbon of nougat, caramel, and peanuts into the familiar rectangular shapes we recognize. What makes this process particularly impressive is the integration of optical sensors that continuously verify each cut meets exact dimensional specifications. These sensors represent a technological advancement that minimizes waste while ensuring every bar maintains the same size and weight standards. Now comes the moment that transforms these layered components into the recognizable Snickers bar, chocolate enrobing. The process begins as the individual pieces pass through a bottom enrober, which coats their undersides before they enter the full enrobing chamber. Here, a curtain of perfectly tempered milk chocolate cascades over each piece, wrapping it in a precisely measured layer of chocolate. The chocolate for this process must be maintained at an exact temperature between 86 degrees Fahrenheit and 88 degrees Fahrenheit, a critical range that ensures proper flow and adhesion. This precise temperature control is non-negotiable, as it determines the chocolate's viscosity and ultimately affects how it adheres to the nougat, caramel, and peanut layers. Even minor fluctuations outside this range could result in a coating that's either too thick or too thin, compromising both appearance and texture. As the chocolate-coated bars emerge from the enrober, they travel across specialized vibrating grates made of stainless steel. These grates serve a crucial dual purpose that many consumers would never consider. The gentle vibration ensures the chocolate coating distributes evenly across every surface while simultaneously eliminating any trapped air pockets that could create imperfections. This seemingly simple step is essential for creating the smooth, flawless finish that consumers expect. Before the chocolate can fully set, the bars pass under a decorative roller that imprints each with the signature swirl pattern that makes Snickers instantly recognizable. This subtle touch adds a distinctive visual element to the product, transforming what could be a plain chocolate-covered bar into an iconic brand identity. The newly coated bars then enter a 15-meter cooling tunnel featuring a carefully calibrated temperature gradient. Starting at 88 degrees Fahrenheit and gradually decreasing to 65 degrees Fahrenheit, this controlled environment ensures the chocolate crystallizes properly, developing the right molecular structure for that characteristic snap and shine. The dwell time, how long each bar spends in the tunnel, is precisely controlled to allow complete crystallization of the cocoa butter within the chocolate, preventing defects like blooming or cracking that could affect shelf life and consumer appeal. The legacy of the Snickers bar goes far beyond its creation in 1930. What makes this candy remarkable is how Mars has transformed a complex recipe into a manufacturing masterpiece that delivers identical results year after year. This global consistency didn't happen by accident. It's the culmination of 9 decades of continuous refinement where engineering precision meets food science expertise. Behind every Snickers is an intricate manufacturing ecosystem where quality control standards are meticulously enforced across all production facilities worldwide. This dedication to consistency has built unshakable consumer trust that transcends borders. Whether manufactured in America, Europe, or Asia, the unmistakable taste of a Snickers remains reliably unchanged, the ultimate testament to modern food manufacturing excellence.